Welcome to JCE Connect. In the yesterday's class, we were discussing about the details of the septic tank and the soak pit, and there we have studied what is the purpose of installing the septic tank and what is the purpose of installing the soak pit. Normally, the septic tank is going to uh, degrade or decompose the whatever the human faces that they are in the sewage, that is going to degraded or it is decomposed with the help of anaerobic bacteria. Once the sewage or the organic matter or the human faces are degraded, then it is going to be destabilized. Once it is destabilized, uh, then it is going to uh, lose its potential. Then automatically it is going to move towards the settling property. Then whatever uh, the settled one sludge, normally that sludge will be there, that sludge will be transferred to the soak pit, where uh, it will be uh, completely disposed with the help of soak pit. Sometimes you have two types of soak pits are there. One is the lined one and one more is the unlined one. Today what we'll do is that we'll try to estimate the uh, dimensions of the septic tank, how much the quantity we are getting in terms of RCC, in terms of brickworks, in terms of uh, concrete RCC or PCC, or how much excavation is there. There are all the things we'll do it for the septic tank as well as the soak pit. This is very important question for the exam point of view, because two times it has been asked in the examination process. So now on the left hand side of this diagram, you can see that there is a septic tank for the 25 users. Almost all the design details are given in the diagram itself. And the right hand side, you can see that that is a soak pit, that we already seen that. You can see the section on the left hand side of septic tank. First we'll design it for the septic tank, then we'll go for the soak pit. So when you are seeing in the section you can see that the width of the septic tank and the height, and in the plan you can see that the length and the width. Same we can see in the soak pit itself. So if you see the section of the septic tank, they have given some details. If you go through the question, it consists of the first class brickwork of 1:4 cement mortar for the foundation. For the foundation, they are using 1:4 cement mortar, and the floor, whatever the floor is there, they are using it for 1:3:6 cement concrete. For foundation, they are using only cement mortar, which is of the specification of 1:4. You have to remember all these things when you are doing the calculation part. The floor, they have designed it for 1:3:6 cement mortar. So then inside the septic tank, they are using 12 cement mortar. That is for the plastering. They are using 12 cement. Thickness will be 12 and it has to be finished with 20 cement plaster of 1:4. 3 mortar mixed. Thickness above that, whatever the 12 mm they are placing, then it has to be finished with 20 mm above that they have to make it. Then upper and the lower portion of the whatever the soak pit, if you see, it is made up of second class brick. Whatever the soak pit is there, it is made up of second class bricks. And the septic tank, whatever it is there, it is made up of the first class brick. That also you have to remember. That is in the ratio of whatever the second class bricks they are placing, with a ratio of 1:6 cement mortar that has to be provided. The portion is whatever the cement mortar they are mixing, that is 1:6. And the middle portion, it is made up of the dry brick work. Means if you see the soak pit, if you see the middle portion, this is what we can see. The middle portion, it is made up of the soak pit. Then the roof, whatever the roof covering the slabs and the baffle walls, it is made up of precast RCC. Whatever the slabs you are talking about, that is made up of the RCC. Whatever the slab you can see, this portion we can see this is the made up of precast RCC. The length of the connecting pipe from latrine seat may be taken as 3 meters. Whatever the pipe length of the latrine, it is taken as the 3 meters. Whenever you are calculating the amount, if they sometimes they will ask only the quantity of the whatever the work, that is a septic tank quantity in terms of brickworks or in terms of excavation, in terms of RCC work. Sometimes they will ask the total quantity, the price, whatever the rate per excavation, rate per RCC. Then I have already supplied the SR, the recent SR rates, PWD SR rates. Then what you have to do is that according to that you have to use that calculation and you have to do it. Most of the times they will ask only the quantity estimation. Sometimes if they ask, you are supposed to remember some of the things, and sometimes the PWD SR will be given to you in the examination if they ask the rates, or you have to assume the suitable rates and you have to calculate it if they have asked the total quantity or total price of the septic tank. So now if you see the septic tank, the first one, if you see the section of the septic tank, at the bottom it is made up of 1:3:6. That height is of 20 meter, and which is a slope of 1:20. So they have made it slope in a such a way that whatever the sludge, what I said that a destabilized sludge is there, it is going to settle and it has to move towards the left hand side of the diagram. Means whatever the sludge is there, it should not be settled at one point. It has to move and it has to be taken and it has to be made as a manure for the further use. So how much sludge is going to settle, then it has to be taken out. Then above that you have two layers of bricks is there. There's a first layer. This is the first layer of bricks, and above that we have a second layer of bricks. Similarly, if you see the bottom portion of the work, that is made up of RCC, and Below that you have a 1:4 cement mortar bricks, that is made up of first class bricks. Then we'll start with the excavation. So then this is the first one is earthwork excavation. In that earthwork excavation, if you see the length will be 2.8. How this 2.8 has been calculated? We can see this is how it can be calculated. 2.8, this is 200, whatever the distance. Then in this you can see that this side it is 40 and this side it is 40. So then it is 200, on the left hand side it is 40 and the right hand side it is 40. Then the breadth is 1.7. If you see the breadth, it is 90. Inside it is 90 is there. Then 40 on this side, 40 on that side. So 90 plus 40 plus 40. So that is total. You will get it 1.7. Then if you see the depth, that is 60 it is there, then above that 40 it is there. Then when you are calculating the height of the sloped area of the cement concrete, the calculation should be done in this way. You can see that whatever the dimensions they have given, that is in terms of centimeters. So that is very important. Whatever the dimensions they have mentioned in the figure, that is dimensions. If you see that whatever it is of triangular shape, when you are calculating the triangular shape, the height is 10 centimeter they have given. Then whatever the height that is there, that should be taken as the divide by 0 on the other side and 0.01, then that should be divided by 2. This is how it should be calculated in the height, that is 30, that is height is there, 140 height is there, then 10 divided by 2, that stands for the whatever the sloped area, then plus 20. So then 10 total will get it 1.95. Then total quantity of the earthwork excavation is 9.28 meter cube. Next come to the cement concrete. Cement concrete of 1:3:6, and in that if you see the floor and foundation, that 2.8 we have already calculated, and 1.7 meter it will remains same. Then that is 0.2 meter, that is the breadth. If you see the cement concrete breadth they have given in the diagram, that is 20 centimeter they have given, that you have to take it. Then the second portion, that is sloping floor, that is cement concrete of 1:3:6, that is sloping floor is there, that is number is only one, because only one portion is there. Even floor and foundation is also only one, it is there. See, for the length it is 2 meters there. Inside if you see the floor, if you see here it is 200 centimeter is there. So that is the inside only, or that is 2. Then 0.9, that is the inside breadth they have given, that is a breadth. Then height that we have already calculated, that is 0.05. Then if you calculate the total volume of the cement concrete, that is 0.95 plus 0.09, that is 1.04 meter cube. Then I already said that the foundation, it is made up of first class brickwork of 1:4 cement mortar. Then that can be calculated with help of this calculation. If you see the diagram of this one set, um, this one is there, 1:4. Above that you have one more set of this one is there. You can use the long wall method and the short wall method. So when you are calculating the long wall method and the short wall method, consider the length of the plan, that is in terms of the long wall. When you are considering the short wall method, you consider the breadth of the section. Then if you are calculating in that way, the first one is long wall method, that is the first step. In the first step, there are long walls, or two are there in the first step. The length will be 2.6 and the breadth will be 0.3 and the height will be 0.6. Then total you will get it, if you multiply by 2.6 and 0.3 and 0.6, you will get it 0.94. That is the first step. And the second step, for the long walls, there also your two numbers, parallelly two numbers are there. So that is 2.4 length, it is there. Then 0.2, that is the breadth. Then 1.15, that is the height. Then total you will get it, if you multiply that, you will get it 1.10. Then when it goes to the short wall, you can say the first step, that is two numbers are there, two number walls. The length will be 0.9. Of course in this it is not visible, but it is a 0.9. In the breadth you can see that it is 0.3 and the height it is 0.6. Then total, if you multiply or if you add all those things, 0.9, 0.3 and 0.6, if you multiply it, so you'll get it 0.32. Then second step, if you see, that is 0.9, 0.2 and 1.15. So that is, you will get it 0.42. Total, if you add starting from the long walls, it will be you'll get it 0.94 plus 1.10 plus 0.32, then 0.42. So total you will get it 2.78 meter cube. This is how we did the calculation. It is nothing but the total quantity we have calculated, that is 2.78 meter cube. Then go to the next item, that is Precast RCC work. So in that you can see that most of the dimensions, once you see it properly, just in your mind you can calculate it, how much will be the length, what will be the cover. So then whatever the cover slab it is there, that length will be, slab is only one, is not two numbers. Then inside length, if you see in the plan, that is 200 centimeter plus 20 plus left hand side, 20 on the right hand side. Then you will get it 2.4 meters of length. Then 1.3, that is the breadth it is there, that also they have mentioned in the section. And if you see the height of that, whatever the height we can see, that is 1.3, that is 90 plus 40, 20 on this side and 20 on other side. So 90 plus 20 plus 20. Then 0.075, that is a slab thickness they have given. Even if you see, that is a 7.5 centimeter RCC pre-slab they have given in the diagram itself. So means it is 0.075 meters. When you say it is 7.5 centimeters, it will be 0.075 meter thickness, or the breadth or height, we can call it as a height. The breadth is 1.3, breadth or the width. Then if you calculate, if you multiply 2.4, 1.3 and 0.075, you will get it 0.234 meter cube. Then the baffle walls of the septic tank, what we have seen, baffle walls they have designed which is of 4 centimeter thickness. Then height, that also they have given, that is 30 plus 15 they have given. Then total it is 45. That is, if you see the diagram, you will come to know. Then the length will be of that also they have given. If you see that, it will be of 100 means that is 1 meter. 1 meter, you can see that in the plan. And if you see in the section, baffle wall section, in that section they have mentioned it is 4 centimeter breadth they have given, means it is 0.04. Then height also you can see in the section, that is 30 plus 15 centimeters. So means 0.3 plus 0.15. So then that is total 0.45. So then 5 centimeter is a bearing for the baffle walls. Then if you calculate it, so that will come around total 1 meters. That's how you have to calculate it. Then this 12 centimeter cement plaster and all those things we will continue it in the next class.